Dr. Vineet Gangya, thank you so much for allowing Neosciencehub to come and talk to you. It's been a pleasure always to come to IICT to visit scientists like you. Can you tell our viewers how did you come here, what was your interest, and how you managed to come to IICT?
So thank you very much for coming it here in IICT. So I'll tell about my journey at how it fascinated me to come to this institute. So I was doing my BTech in chemical engineering. So I am from Ujjain Engineering College, Ujjain. And during that time, what happened? My Professor L.S. Thakur, told me to look for the internship in pilot plants. So during that time, I went to Nagda and Pritampur. These are the areas where pilot plants are in abundant available. So I have visited one plant in Lenses India Private Limited. That was thionyl chloride. So when I seen the pilot plant, I got fascinated with that. So how it is made? I can see the plant is engineering, but what made that plant to be erected? What was the basic chemistry in that, or what was the science was involved? So that was the first. I was in the third year. So I got fascinated with that. How a small set of reaction can be converted from micro level to kilo level and to the bulk production. So that was the first interaction with the science which I had, I think, in 2011. And at that time I thought I should do this. So that was the first step towards the inclination to the science, and that has motivated me to look for the institute where this science can be learned or implemented to a higher scale. So then after that I was in my final year, and I have given GATE also. So by the grace of God I qualified with good marks. So and notification came from CSIR. They were looking for young talented people to work in the science and pursue their MTech as well as PhD, and they can be recruited as a scientist there. So I have applied in 2012, and during that time I was in IIT Kharagpur. So I was doing my masters in IIT Kharagpur, but that was in more of educational field, and this was more in R&D.
Okay.
So I switched from after 2012 I switched from IIT Kharagpur, and then I came here at IICT, and I started my journey of science and engineering in here. And after that, no stop, like it is 2025 now, almost I have rendered 14-year services, and I have learned a lot in this area, and I hope in future I will be continuing this journey.
Dr. Gangya, you touched on process engineering. From that time to this time, what are the opportunities and challenges you think in this field?
Yeah. So now, like process engineering is nothing like it is a bridge between a chemistry and industrialization. So basically process engineering done by chemical engineering, and chemical engineering is a very old discipline.
Right.
So and over the duration chemical engineering is evolving by adopting new principles. One is process intensification, then now with the implementation of technology, AI is coming into picture, then automation is also coming into picture. So when you look to the journey of process engineering, so it has evolved over the years, and now new techniques as per the modern technology are implemented. So now process engineering is growing very fast. So if you want to take up a process from lab scale to a commercial plant, so you need to a process engineer that should have a discipline of chemical engineering, mechanical engineering, instrumentation engineering. So all these engineers work together to do the process engineering. So now for any technology to go to the market, you need a process engineering to be done, and most important crux comes from the intensification. Now most of the technologies are developed. If you look at the world technologies, all technologies are matured. Either it is refinery, petroleum, or whatever, they are matured. Now as we are moving towards sustainability, or 2050 or 2047, the goal which is there, the government as India for decarbonization. So to achieve the decarbonization or sustainable goals, now process engineering has to take a lead where they do the engineering and intensification, particularly where they reduce the carbon footprint, that is decarbonization need to be done first of all. Then they should look for the sustainable sources. Either they can be bio-based sources, as you are aware that are whatever the fossil resources which we are using right now, they will be there more than 100 or 200. Coal will deplete in 1 or 2.
Right.
So we need a bio-based feedstock. So second part is the getting a feedstock which is a sustainable or which can be grown within the earth itself. Then comes the AI, because to do the engineering you cannot do trial and error. Once you erect a plant, it should work. So now with the modernization of technology, now we have AI tools, or you can say simulation tools. Earlier it was simulation tools where the predictions was done for a process plant, like suppose Aspen Plus, MATLAB, and all these codings were done earlier to understand the performance evaluation. So that was a third part. So taking this all this into a one holistic overview. The process engineering now is advancing in this, and they are trying to implement new approaches. Now in the process engineering, one more tool has emerged, that is called life cycle assessment. So a process engineer, to do a good type of engineering, he need to understand the footprint of the process also at the end of life. So if you are aware of this, new softwares are coming like from Gabi and Simapro, they do the life cycle of the process, like from gate to cradle, and the entire footprints will be covered. And their process engineer can understand where the criticality of the reactions will be there. So now this is one of the another vertical in the for the process engineers to work on. Apart from the digitalization, what I talked about, intensification, and in the intensification field also, like flow reactors. Like traditional approach was the batch reactor, which was used over the century. Now also in India, we rely on the pharma as a batch reactor.
Correct.
Now with the changing time and to reduce the energy and safety standards, flow reactors are coming. Now the pharma, like since Hyderabad is the biggest pharma hub in India, and it will be growing, the pharma sector will be growing very fast. So people are switching from batch to continuous, and batch to continuous also they are shifting to flow reactors, which can have a miniature, like putting a pilot plant in a room size itself. So that is advanced technology which are being implemented, and there to operate that, process engineers need to understand the complexities, and they need to overall design such that it will give the desired product in less time and with greater yield, and reducing the economics also. So this how the process engineers role are, like it is not limited to one thing. They have to have a wider scope to work, and lot of areas are there in the entire engineering fraternity where process engineers are very critical now.
Brilliant. You touched on a couple of things which I recall. You spoke about biofuel, you spoke about sustainability, and you spoke about life cycle.
Yeah.
Let me start with biofuel. And I know I have gone through your background. You have a very highly cited paper on biodiesel. Can you please tell our viewers about that?
So that paper is closer to my heart. Like this was the first publication of my research career. So when I came to ISCT, like here one project was going by MNRE, where government has initiated to work on biodiesel as substitute to the diesel fuel which is there. So there the work was particularly to develop a feedstock which can be a renewable, or which is not having a fight with the food system. Like if you go for edible oil, like in the foreign countries, if you are aware, they use the cooking oil. Once it is used, they discard. But in India, we will use until it is exhausted. So what government thought, if we can come up with oil which is something which can be grown easily, or which but that people will not eat it. So Karanja was one of the feedstock. So Karanja based oil was derived from, we have worked on the Karanja based system where we derived the oil and done the esterification and produced the biodiesel. So there also interesting study how engineering was implemented. Since this oil, when the reaction happens, there is a mass transfer resistance. So you need to overcome the mass transfer reaction to move the reaction forward. So we have critically studied that residence time as well as the mixing patterns. Again through process intensification was implemented in that. How we can intensify the reaction time and operation time as well as parameters where this reduction and mass transfer can take place. So that was studied, and beautifully we conducted studies on different temperature pressures, and we come up with a holistic overview where a model was developed for that. So if an oil is there and you have such set of parameters, you can use that model to predict this behavior. So there again engineering and production was done. So to scale up at higher scale. And then we have come up with an overall study on that. And in ISCT, one biodiesel pilot plant was also erected during that time. But since what happened, the plantation was not enough in India. It was a good policy by government, but the plantation was not that much enough. So the project was little bit hampered and slow right now. So people are now exploring new feedstock also where this biodiesel can be produced.
Brilliant. And I also know that you work on tertiary butyl alcohol as a fuel.
Yeah.
Now, is this complementing or is it competing each other? How is it?
No, third butyl alcohol, like it is one of the key ingredients which goes into MTB production, to my best knowledge, and I did my PhD in that area only. So that in third butyl alcohol, what happened? It forms in isotropit water. So that study I have took, my guide Dr. Satyavati has given the topic to me. So they have worked on the separation of third butyl alcohol water. So it is a complementing into the application part, not directly to the biodiesel part. So they are far apart from each other, but it has a different application. It goes fired, like you can produce MTBE out of it or any other gasoline based product. It goes in blending also. So that are far apart from it.
Okay. Good. My next question to you is, let's say about sustainability.
Yeah, that is a hot topic now, and I would like to speak on that.
Yes. So I want you to educate our young viewers.
Yeah. So this is the sustainability is a buzzword first of all, but
Absolutely.
we need to work on sustainable practices. Earlier we used to do. When the old, like if you see 300 years ago, we used to work on sustainable practice only.
Correct.
But as the industrialization, modernization happened, now sustainability has gone.
Absolutely.
But now we understood again the resources are getting depleted, again we are coming back.
Absolutely.
So to educate a normal audience, what is sustainability? Basically sustainability means here anything which can be grown in the nature. Sustainable, like it is not fossil. Once used, it is exhausted. So anything which can be regrown or which can be regenerated from the mother earth, reused enough at the final end of life. If it cannot be used, it can be gone back to the earth. So we are taking from the earth, we are giving back to earth.
Absolutely.
So that is the definition of sustainability, which sustains itself. You need not to give a push to you use it, but the end of life it goes back and again you can regenerate. So that is sustainability. At ISCT, what we are working on sustainable plastics or biodegradable plastics right now. So I'd like to brief more about it. So at ISCT, like we are developing, as you are aware, India, we have plenty availability of cornstarch. We are the biggest manufacturer. So this cornstarch has a application in plastic. You can make plastic out of it. So what ISCT has done, we have modified the starch by reinforcing with nanocellulose. Nanocellulose is one of screening, but that is a filler which can be used. And we have prepared a thermoplastic starch. And this granule, what we have prepared, we have mixed with one other polymer, that is a polyester, but it is a compostable, and we have made up a carry bag. So one technology was given by ISCT to Greenworks India Private Limited. It is a subsidiary of Apollo Pharmacy. So if you go to any pharmacy in Hyderabad, not Apollo Pharmacy, you will see a ISCT logo. So our technology has been implemented in a sustainable practice to an industry where it has a commercial exploitation. So this is our journey which we have done in sustainability. Apart from the sustainable projects which we are working, we are converting bio-based feedstocks to different chemicals. And one more thing, for India, sustainability is more important because we import a lot of feedstock. All the chemicals comes from China. So all the key ingredients, all the APIs, whatever you talk about, it comes from China. And they are synthetically derived. So already they are 50 years or 100 years ahead of us. You cannot beat them. So for India, to my perception, my personal views there, we can make that same products by using bio-based resources. Maybe the pricing are very high today. It may not look lucrative for the industries, but down the 50 years when this exhaust. So today if you prepare for the sustainable products from the bio-based feedstocks, then we will be in the picture down the 50 years, how China is today there in the world market. Then we can be there in that 50 years with the sustainable products in the market.
Superb. Then my last question on that is life cycle.
Yeah.
Now let's talk about life cycle. How will a chemical based product achieve a life cycle?
Yeah. So when we talk about life cycle assessment of a product, now before you start a product or manufacture a product into a market, government or any agency asks about its footprints, either in terms of emissions or end of life.
Sure.
During the process of production or during the usage or end of life. So during this time, now this life cycle tool is a very good tool where you can calculate at each steps. Like once when it is harvested, suppose let us take an example, when we did for the biodegradable plastic, what I will take an example of that only. So the corn is harvested. For harvesting the corn, how much environmental footprints have been generated? That is the life of that corn to plant to cornstarch, then cornstarch to granules. When we process through machineries, you used electricity. Electricity was it was produced from dams,
Correct.
thermal power, or it was a coal power plant. If the coal power plant was there, CO2 was generated. So you have, for every steps you are calculating the footprints, either in terms of CO2 or in terms of heat or any whatever excess, it has to be taken into consideration. Then finally usage. When we talk about biodegradable plastics, we use it, we are using from the market, and when we are throwing it, at the end of life also it decomposes to CO2. Right. So again footprint comes. So this life cycle tells us the entire journey from starting to ending, where you can understand if you develop a new product, how much it will give to environment in terms of pollution also you'll come to know, or how much revenue, or how much, not revenue, it can be how much it will give emissions overall to the environment, that can be estimated. So this is a very much important tool for all pharma companies also, the life cycle assessment, and I think it has been made compulsory for most of the industries now. They are doing and dedicated departments are there to study the life cycle of a product.
Yes.
And this is the future. Sustainability and life cycle assessments for anything has to be done to make a product profitable, or to reach our goal for sustainability for longer time.
Very nice, very nice. So now slightly digressing, you are using technology, for example, SpinChem RVR.
Yeah.
You've been using it. Can you just brief us about what are your plans, what application you will be using for that?
So in the initial discussion, we were talking about process intensification. So I think we have introduced to this technology, I think 3-4 years back, and this spin basket reactor is a very interesting reactor. When I have talked of biodiesel, their mass transfer limitation was there. So it is a good example to use such type of spin basket reactor, such type of technology, where you can intensify your operation. They intensify the mass transfer, they reduce the mass transfer resistance and increase the speed of time.
Okay.
So this spin basket reactor can be used for wide application. It cannot be, because I was exploring the possibility when I have gone through the catalog of the company, it was talking about bioenzymes or something enzymatic things we were talking, or biotransformation. But it can be implemented to other pharma industries also. How it can be done, I will take an example. Like let us talk about unsustainable practice, let us talk about sustainability. When we talk about PET depolymerization, so where heterogeneity is there between two phases. So this type of basket, you can have a heterogeneous mixture in the basket itself and the reaction media in the outside. And suppose the reaction is solid liquid and the product is liquid. So automatically over the reaction, the material moves out of the basket and the limitation of the mass transfer will not be there. So it will intensify your, first of all, downstreaming. Downstreaming also is not challenging in this type of reactor. Suppose impurities are there, then the impurities remain in the basket itself. Second thing, if you are having a heterogeneous catalyst in this, so the dispersion will not be there in the entire system. It will be in the basket, and you can not to separate every time in the downstreaming. Third thing, you are reducing the time duration of your reaction. So if you are having 1 hour reaction in this basket reactor, we assume that it can be done within 30 minutes or 15 minutes time, because it is intensifying. Rate of reaction will be enhanced. So overall, it is a new technology that need to be implemented and explored, and need to be fine-tuned, because a simple spin basket reactor will not suffice all the application. You need to fine-tune it to your end application, and you need to modify as per your requirement. But I think that this basket reactor seems to be a good technology where more modifications can be done, and existing technology is great, but you can think of more modifications in the existing system, and it have a wider scope in pharma as well as API industries also.
So where do you think would be an application of this apart from the lab?
This basket reactor right now we are using, and how we are using right now, we are working on a project on PET depolymerization. So we are depolymerizing the PET bottle and converting into diactyl terephthalate as a plasticizer. So when we were doing in a conventional reactor, what happens? It took time to depolymerize and the reaction to take place. So you have two phases of reaction. And when we have purchased this equipment and we try to implement the same reaction, so what we observed, your depolymerization also happened as well as reaction also started. So the dual functionality this reactor has provided us, and through that we were able to reduce the time duration of reaction. And time duration is reduced. The beauty, because the reaction was conducted in 220 degrees centigrade. So you can assume that when we are operating a plant or a higher capacity, a reduction of 1 hour will definitely affect our energy balance of the system, because temperatures are high, so you need to supply more electricity to that. So overall your economics can come down. So this basket not only have a good performance on the process parameters, it has also an economical parameter also, which can be very much more important for an industry where economics has to be considered.
Correct. Doctor, India is a developing economy, and a lot of plastics are being used, and that is actually going down in the green and all. And it's creating a lot of big menace as a pollution. So what is your opinion on that, and how to handle that?
Yeah, this is a hot burning topic right now. So government is also very much serious on this topic, and they have introduced some laws recently in 2019 and 2021 also it was implemented, that government has banned almost 20-30 materials of plastic which are called single-use plastic. To define single-use plastic, it means a plastic which is used one and throw into the landfilling or dump yard, and which cannot be recycled also. So to address this issue, people are working on biodegradable plastics, because what happens, some of the plastic acid cannot be recycled due to manufacturing issues, or people would not like to use it second time also, and there are a lot of issues with the single use plastic. So government has come up with new initiatives where we can develop biodegradable plastics. So in that initiative, like at CSR IICT also and various institute across the India, people are developing new biopolymers which at the end of life are compostable. And like some of the polymers, like I'd like to mention, like thermoplastic starch, then polybutyl adapted terephthalate PBAT, PLA, and apart from PBS. So there are series of polymers which have been right now emerging which can be used to synthesize the single-use plastic. The problem with the India right now, to implement we can do it easily. So, but the problem we don't have the raw materials. Again, we are dependent on the imports. So now the government is pressing to make the raw material itself. So now, like I think in Uttar Pradesh, PLA plant is coming up. So that will be a very game changer for us, where this compostable products can be made very fast. So that will have a significant effect on the plastic pollution, particularly all the carry bags. In that effort also, IICT also worked. So recently, like if you see, this technology was given to Apollo Pharmacy, that Green works, where IICT has developed this technology.
Very nice.
And this is a compostable plastic, and we have got certified by CPET. So CPET and CPCB are involved in this. So we have to get certification, and this bag is compostable in 150 to 180 days. So if you put in an industrial composter, it will degrade into CO2, and and again you can again it basically at the end of life it is no pollution is there. So this how, like, researchers as well as government are putting more efforts, where you need to use compostable material. Similarly, like if you see the cutleries, when we go aeroplane, trains, wherever, we use the spoons, and when we throw it goes into littering. Recycling is difficult because segregation is not there.
Correct.
So we have also developed similar to that, and different labs are also working where they are coming with a compostable cutlery. Recently we are working on one more project with National Textile Mission. So as you are aware, we wear the cloth, we use it 2-3 years whatever, and the end of life either we make a pocha and it goes to dustbin. Correct. Nobody use it.
Correct.
And if it is cotton, it will degrade.
Yes.
But we are using polyester cloths.
Correct.
All the different. So one initiative we have taken, and we are working on the compostable polyesters. So this is one of the compostable polymer which we are making, where this polyester is again at the end of life, if you put in a composter, it will degrade into soil. So this is a good initiative like by the government of India, where they are promoting this type of products. So we have been funded by government to work on this area, and we are closely working with other institutes also who can do the manufacturing, because at our institute we are into process development, scale up design. So we will put our scope work to the product development, and at the end of life, where this raw material will go to either to a textile industry or somewhere where they make the shirts or any apparel out of it, which can be used for the end application. So this is also one of the second initiative where we are focusing on textile waste. One is the plastic waste I told, and textile waste. Likewise, lot of verticals are there, particularly for the plastic pollution, where we can work on right now, and people are working. Like I think after this government mindset on particularly Swachh Bharat mission, mindset has changed. I can see personally, people are working on this area, and alternatives are coming, and our social people are now feeling socially responsible to take up more initiatives. You will see lot of drives will be there, like for cleaning, and earlier I have not seen never. So people are also taking it seriously, and researchers are also coming up with a good technology. I see like within 2050, like India will be able to tackle a certain pollution has to be like, we will be able to tackle all these challenges which right now we are facing, and I hope India will be clean and green.
Absolutely. Just for the benefit of viewers, when you say compostable, means it will degrade and form of soil.
Yeah. So when we talk about compostable, what it means, under a certain set of condition, like composter is there. When you put in a soil in a certain set of 50 degree or 40 degree, it will decompose into its original source. Basically, these are hydrocarbons. when you everything in around it is hydrocarbon, either H or C,
Absolutely.
and O and other things will be there in that. But backbone H and C. So when you put in a composter, it starts to degrade, and it goes to an original carbon source into the soil itself. And then again, it can be used. It is a manure, or you can assume that it has gone to the soil as a hydrocarbon source, but it will not contaminate the environment.
What is your opinion on a science magazine called Neoscience Hub?
Yeah, Neosciencehub. So I remember like the first edition when from your team somebody has came. So it is like this magazine is basically a popular magazine. What I observed where the lot of science articles are available, and what are the things which are going across the world which has been discussed here, and what are the mindsets which are there. People think about the science that has been mentioned. So I think this Neosciencehub provides a variety of articles in different domains, not limited to engineering, not limited to biomedical. So it has a wider scope where what we need, what people are doing, what need to be done, that has been covered. And it is a futuristic magazine where you can contribute also, like if you have any scientific things that it will be shared, that you can do it also. So this monthly magazine, we find it very interesting, and I'm a regular reader of this magazine, and lot of updates we are getting, and I hope more interesting articles in this magazine in the upcoming future.
Thank you so much, Doctor, for this kind work. It was a brilliant talking to you. As always, it's nice talking to a scientist. Thank you so much.
Thank you for coming, sir. Thank you very much.